Hello everyone. So this is starting week 2, and we're going to start getting into our program design and problem solving. So we first need to understand that when we write a program and of any language, we are doing so to solve a problem. As we talked about last week during our software development life cycle, we have a specific problem that we need to solve. We analyze that problem and then come up with the design and implementation and maintenance and so on and so forth. So in that process, and we'll talk about this here in just a few minutes, we have to identify we have to identify and analyze that problem and be able to solve that problem with our code and solve that problem well. So let's take a look at the planning phases of that. So the presentation of our code is so very important, and it's going to be more and more important as time goes on, as our programs get longer. You've probably noticed that I've kind of harped a little bit on making sure that the code is formatted properly, meaning that that code within the curly brackets is indented to a certain extent, so it's more readable. And we'll see later on as we get more modules in our program that that's going to be more and more important. So when we use a modular design, this is going to be kind of a top-down approach, and this means that the program that we identify in our original analysis is broken up into sub problems or sub programs, and then we attack each sub problem individually. So there are a lot of advantages for this modular design. One of the main reasons that this is advantageous is that as we break those problems down, and this is certainly true for software development companies that have huge applications, those sub-problems or sub-modules are given to individual teams, and that team will work on the problems and be given the criteria saying, okay, well, you have these values of data coming in, and we need you to do some specific task to those values and then return some other value. So let's take a look real quick of how that might look, and this is going to be kind of an introduction to what our pseudocode is going to look like as well. Okay, so we've got this is what our pseudocode is going to look like initially, and you'll see that we have a main module and then we have submodules beneath that. And the way that this is designed, pretty much everything is contained in a single program of sorts, and but we still have it broken up into modules to make it easier to code and easier to read and so on and so forth. So we start out with our main module. Every application that we write in this class will start with main. Now, different high-level applications or high-level programming languages have different structures and different syntax, but it's all fundamentally the same. So in this class, we are going to start with the main module. And by the way, so I've mentioned this to a couple of folks. We're going to presume that all 32 of us are part of an individual software development team. So when we write these programs, these pseudocode programs, we are bringing this to our development meeting and say, okay, this is the design that I have come up with to resolve our issue. So this is going to be the pseudocode format and the pseudocode syntax that we're going to use in this class. Now, when you get out into the industry, as you start developing pseudocode for those meetings, different organizations have different syntax of pseudocode, and you'll see all kinds of different flavors. So if you start doing search online and start Googling pseudocode or pseudocode syntax, you're going to find a million different types of syntax. So I'd like to keep everything standard for the class. So let's kind of stick with this basic design, and it's going to make our software development meetings go a lot smoother. So once again, we start with the main module, and that module is going to end with end module. And inside that module, we're going to have declaration statements that are going to declare our variables. Now, again, not all high-level programming languages require you to declare the variables before you use them. You can kind of create them on the fly. It's better in this class to understand what's going on with those variables if we do it in this way. So please make sure that you declare your variables, and the syntax for that is declare the variable name as and the data type. And we'll talk about the data type here in just a little bit. But this is going to be the syntax that we're going to use. Is declare variable name as data type, and not declare variable name as a string or as a float, or declare three variables in a row as floats, plural. So now, that being said, if you do have a number of variables of the same data type, you can do this. You can have declare original price discount rate as float, and that will create two variable locations in memory with a data type float. And again, I can include all of these in the same line. So it's important to understand what's actually going on when this happens. So when we declare a variable as a specific data type, it allocates a location in memory with that data type, and only that data type can live in that location. And that's going to be very important later on, and we'll get into that here shortly. But in any event, so we've got some information out to the user, and then we have a line to call our submodules. So we call input data submodule and ask the user to and it's very important that you give the user specific information on what they're required to use. So it's sometimes difficult to make that paradigm switch and think about what the user is going to see, and what and make sure that they have enough information to enter precisely what the program needs. So in other words, you can't have an instruction that will say what is the item's name, price, and discount percentage all in one line, and then have 3 input statements. That's just not going to work, because the user's going to be confused, and your program's going to crash. So at any rate, so we call the input data module, and it goes down here to this location. And now, by the way, there was someone that asked how those programs know where to come back to. So there's actually a program stack that keeps that address location for where it left. It goes down to here and executes the information or the processes in this input data module, and then comes back to the location in that data stack, and then goes to the next line and performs that function. In this case, it's call perform calculations module. Goes down here, executes the processes in this submodule, goes back up to the address in this data stack or process stack, and then it calls the output results module. So this is the modular design that we're going to use in this class. Now, it's going to take a little while for you to get the hang of all this, and I'll put this information up in the in our discussion area in the classroom, so you have access to that. So let's go back to the slides, and we'll cover a few other things. So as I mentioned, this that process is sort of it's a top-down or stepwise refinement, and that it basically means to take the original problem based on the analysis that we did, and break those down into sub-problems and then problems beneath that, and that will result in eventually that modular design. And that step is really important when you're doing that analysis, to define what the initial problem is and what the sub-problems are in that analysis, and we're going to be defining that analysis in our assignments. And again, this is like I said, it's the top-down approach, and we will focus on specific control structures. This class is designed to identify the control structures that you'll see in writing programs, and that includes a sequential control structure, a selection control structure, and an iteration control structure. And those are the only three, effectively, that you'll be using when writing code. So if anyone has had any experience in basic programming or anything like that years ago, you probably recall some go-to statements and the like. Don't use go-to statements. This is very, very important that when you're writing your code, that you have absolute control of where the data processing goes from one location to the other, and using a go-to statement just doesn't do that. Anyway, we don't have a go-to statement in our pseudocode syntax. So that being the case, every module, to include main and the modules beneath main, will have one entry and one exit. This means that if you have a submodule and then you have a control statement in there that tests for a certain condition, you can't exit out of that module from that control structure, in addition to having another exit at the end of the module. So, and we have three basic statements that we're going to be covering. It's an assignment statement, input statement, and output, and we'll see all those as we press forward. So this week we're gonna start covering some flow charting, and again, this gets back into the one entry and one exit, and this translates very well to flow charting, because as you'll see in our flow charts, that module has one entry and one exit. And make sure that when you're designing your flowcharts that you design those very carefully, because the flowcharts are intended to show the paths of processing rather than module-to-module communication. So that means that if you have 5 modules in your program to include the main module, that doesn't necessarily mean that you're going to have 5 modules in your pseudocode. I'm sorry, in your flowchart. It's just we'll see how that works a little later on as well. So this is what our flowcharts are going to look like, and on the left side here, this is the sequential control structure that I was speaking of before, and basically it's one statement and then the next statement and then the next statement, and that's the sequential control. And then to the right of that is a selection control structure. So it tests if a specific condition is true. If it's true, then it does one statement. If it's not true, then it does something else. So if this condition is true, then do this, else do this. And there's also a case statement which is similar to that, but it actually tests for more than 2 cases. And then you have an iteration type control structure, and basically that is a loop. It gets into that loop, and it repeats the contents of that loop a specific number of times, and that's based on conditions and so on and so forth. So in this demonstration, or this illustration, this has a repeat until figure that can be used in our flowchart, or a while do. So getting back to the our software development lifecycle, we're kind of revisiting this a little bit, and our class is effectively going to be is certainly going to be in the design portion of this software development lifecycle, but more specifically, it's going to be in one segment of that design step, and that is creating the algorithm that is going to be used to write our code, and that the pseudocode is our algorithm to write our code, and and not all software development teams use those algorithms or use flowcharts, but it's really important to start with those flowcharts very early on as you're beginning with your software development paths. So, and that that does a really good job of showing what those the process flow is and what is actually happening with the processing and the variables and so on and so forth. So again, we have to have an algorithm in our software development lifecycle. We have to have an algorithm before we start writing our code, and pseudocode is going to be that. And we're going to use flowcharts to show that the flow in our algorithm. So we have as I mentioned before, we will declare variables, and a variable is a specific memory location, and the reason it's called a variable is because the value of that memory location can change. Now, there are certain exceptions to this. There could be variables that are identified as constants, and of course those variable locations, variable values are not going to change. The identifier for that variable is basically the label or the name that is assigned to that memory location. So the identifier is in itself, it's the variable name. In this class, we're going to stick with the basic data types, and I'll cover that in just a moment. And now it's important to note in this class that as we declare a variable to a specific data type, it's going to stay that data type for the lifetime of that variable. Now, there are certain exceptions. In C++, you can typecast variables to other data types, but in this class, we're going to stick with the data type that is declared for that variable. It will remain that data type for the duration of that or the lifetime of that variable. So this is one thing that is very, very important. All of our variables will have meaning. That means that and this is done so as our programs get longer, that the variable that we declare up in main will have meaning when it gets down to the fifth submodule, and we know what that's for. So we're not going to use single letter variables or A1 or T1 or M3 or something like that. It's going to be something that you can see in that variable name and tell what that variable is being used for. Now, that being said, there are some of the hands-on labs in this class go against that. It has single letter variables A, B, and C, and X, Y, and Z. I didn't author the hands-on labs, so I can't change them. But anyway, just do me a favor when you are submitting discussion posts with pseudocode and you are declaring variables, make sure that you do not use single letter variables in the pseudocode, and especially in your assignments. In your assignments, I just don't want to see it. So these are the data types that we're going to be using, and the top four are primarily the ones that we're going to be using. The integers, float, character, string, and then Boolean. Integers, of course, are whole numbers, and then floats are a fractional value of those whole numbers. Now, it's important to remember that when you're declaring your variables, that if you are going to later be using the value in those memory locations in mathematic functions, that you declare them as either integer or float. Because if you declare them as character or string, you cannot perform mathematic operations on those. So, and then the character data type is, as the name suggests, it can only hold a single character, such as a Y or an N. So in other words, you can't declare a variable as a character and then try to store a name in it. It's only going to take that first character of the name. And then there's a string data type, of course, that is a string of characters, and that's what you're going to be using for person's names or cities' names or something like that. And again, arithmetic operations can only be used on values, numeric values, variables with a numeric data type, whether it's an integer or a float or something like that. Now, keep in mind that if you're going to be using those mathematic functions, like for instance a division, make sure that that the result of that division goes into a memory location that can hold the result of that. So in other words, if you do a division, it's very likely that that result is going to be a float value. So it's a good idea to declare that variable as a float. And make sure that you read through those the online modules in the classroom, because there's a lot more information on that. And then there's a hierarchy of operations. That means that if you have a line of mathematical operations, these are the steps that they're going to happen in order. The exponential values are going to be performed first, the exponential values and the roots, multiplication and division, addition and subtraction, and then those that are in parentheses. So if you have certain steps that that need to happen at certain times, you need to kind of plan where those need to take place, and put certain certain structures in parentheses to make sure they happen at the right time. And we have logical operators, and this is these are kind of difficult for some folks to wrap their brains around, but we'll see more on this later on. A not value is just an exclamation point or a bang. This negates the value of that process. So and again we'll see all that a little later on. There's an AND operator and an OR operator, and if you've never done any kind of logical operations, an AND function basically means that both conditions have to be true in order to give you a true statement out of that result. And with an OR statement, one or the other conditions or both can be true in order to result in that condition being true. And again, we'll see all that a little later. And these are the relational operators. And now this is very important, because if you look at the top of the page there where it has the equals operator, you'll notice that double equals is just to test if one condition is equal to another. So for instance, the example is x equal to y. Now if you just used a single equal sign, it will try to place the value of y into the value of x. So it's very important to remember that when you are using a test condition, that you use that double equal sign. And below that is the not. Again, this is the exclamation point we were talking about earlier. Not equal to. So in the example, it has x not equal to y. So and you can use that in an if-then statement, and say if x is not equal to y, then do this. And then beneath that we have some other operators: greater than, equal to, less than equal to, and again those can all be used in our code as relational operators. We have three basic commands that we're going to be using: set, input, and output. And I think we kind of talked about that a little later, or I'm sorry, a little earlier. So it's very important that you comment your code and comment it well. I can't tell you how often I see someone's code that had been written 4 years ago. Of course, they're no longer around to explain where their brain was when they wrote that code, and there's no documentation in the code. So we effectively have to reverse engineer the code to determine what's going on. So let's take a look real quick at a couple of things with this with our pseudocode and how it's going to be structured, and hopefully we can make that clear before we get too far in this class. Okay, so we talked about the different control structures that we're going to be covering in this class. We have a sequential control structure, which is one command after the other, and then a selective control structure, which is saying if this condition exists, do this, and then we have a loop type control structure. So let's take a look at this, and again we have our main module, and we declare my name as string, and then we call selection demo module and come down here, and you'll notice that we are declaring a new variable in this sub module. Now it's important to understand, at least in this syntax, that that the variables that we declare up here in main are going to be global variables, and they will live for the entire duration of this program. So, and then down here, when we declare a variable within this this submodule, that variable will only be in existence for the duration of this submodule. So when we finish this submodule and then return back up to main, this variable that we defined as case choice as a character will vanish. It will go away, and that memory will be freed up to be used as another memory location. So in any event, we declare our string variable. We call selection demo module, come down here, and then declare case choice as character, and then we have please enter your name, and then we and then input name. So and then we enter a test condition that is an if then else statement. So if the value of my name is equal to Tony, then we're going to output my name as Tony. Or I'm sorry, rather we're going to output my name is in quotation marks. And notice that there's a space here to separate this text from the value within that variable. We're going to output my name is, and then output the contents of the variable that was just changed by the user at this location. So on the other hand, if the user entered something other than Tony, it's going to go say if my name is equal to Tony and my name equals James, then we're going to go down to the else statement and say, and it's going to output your name is not Tony, and it's going to, and this is you're going to end the if statement and then go to the case statement, and it's going to output to the user A, New Belgium fat tire, B, left-hand milk stout, C, Bristol Mass Transit, choose your favorite beer, A, B, or C. And then it's going to wait for the user. This input statement waits for the user to enter some value, and it's going to put that in that variable. And remember that we declare this variable up here as a character, so it can only hold one character. And then it's going to go down to this case statement, and it's going to test whether it's A, B, or C. And if it's one of those, it's going to output the appropriate line. Your favorite beer is fat tire. Your favorite beer is milk stout. Or if you entered something other than A, B, or C, it's going to ask the question, what, you don't like beer? And then it's going to end that module and return back up here to the main module. And remember that it goes into that that process stack and goes to this this module, and it's going to go to the loop demo module. And again, we're going to declare some new variables in this module. We're going to have 3 of them. All of them are going to be integers. And again, I could have done all of this on one line and declare count, in count, and out count as all as integers on the same line. Of course, that line would be declare count, in count, out count as integer, not as integers or as a integer or anything like that. And then so this is a do while demonstration. So do while count is less than 10. Oh, I'm sorry. Up above this we set count to 0. So we do while count is less than 10. I'm sorry, less than equal to 10, and then we increment count by 1 and output count, and then let's change this to a tab rather than a new line. So it's going to write count plus a tab, and then so it's going to iterate through that 10 times, and it's going to increment count each time, and then when count becomes 11, it's going to get to this, back to the top of this do while, and it's going to go through this test condition. If I'm sorry, do while count is less than equal to 10 and it's 11, so it's not going to enter this do while anymore, and it's going to go to end do. And then here's a repeat until, and kind of the same deal. Now you'll see that at the end of this, count is now at the value of 11. So when it gets to this location, it's going to repeat the contents of this control structure, and then and decrement count each time until count is equal to 0. So it's going to do that 10 times, or 11 times rather. Excuse me. And then a for loop. For kind of does the same thing. Now, notice that a for loop behaves a little differently, because the for loop changes the value of your conditioned variable in the first segment of this loop condition. So there are 3 segments. This segment sets the value of that variable to a specific value, and then it enters your test condition to see if that variable, the value in that variable location, meets whatever condition. In this case, it's less than equal to 10, and then this is the action that it takes on that value. Now, in this case, it increments the value by 1. It could decrement, or it could plus 2, do lots of different things in that action segment. But just remember that every for loop construct in this syntax is going to have 3 segments. It's going to set the value, test the value against a certain condition, and then perform some action on that value. And now we can also, and we'll get into this a little later on, but we can nest these control statements. In this case, I have a nested for loop that kind of does the same thing, but the inner for loop goes through its segments, and then it goes back to the outer for loop, and it does that a certain number of times. Now, it's important that you note what goes on here. So notice that our out count is set to 1, and it tests to see if out count is less than equal to 5, and then it says increment out count by 1. So notice the sequence in this. It sets the value and then tests the value, and then before it does that increment, it comes down and enters the guts of that for loop and executes the contents of that for loop. So we get down here to the inner for loop, and we set our end count to 1 and test to see if end count is less than equal to 5, and it is. And before we increment it, we come down here and execute the contents of that for loop, and it's going to write out colon space, and then it's going to output to the screen the value of out count, which in this case is 1, and then in colon space, and then the value of end count, and currently it's 1, and then it's going to loop through that 5 times, and it's going to print out 1 in 1, and then out 1 in 2, out 1 in 3, so on and so forth. So once it gets to 5, then it's going to iterate one more time, and when end count becomes 6, is going to go to this test condition and say it's going to test if n count is less than less than equal to 5, and it is not. So it's going to exit this for loop and go back to the top of this the outer for loop, and it's going to increment out count by 1. So, and then it's going to enter this for loop again. Now, so it's going to make out count 2. So it's going to test to see if out count is less than equal to 5, and it is. So it's going to enter the contents of that outer for loop again. Now notice what happens. So when we get back to this for loop, it's going to behave as if this for loop has never executed before. So it's going to set n count equals to 1, and then test if n count is less than equal to 5, and then execute the contents of it. And it's going to iterate through 5 more times, and then go back out and go back to for loop and increment that to 3. Now it's important to remember that inner for loop, when it breaches that for loop the second time, or the third time, or the fourth time, that it treats that variable or that entire control structure as if it had never seen it before. So that's a pretty good demonstration, I think, of all the control structures, or most of the control structures that we're going to use in this class. Just so I'll post that in the classroom as well, and you guys can take a look at that. And if and again, just keep this in your mind for right now. As we start writing our pseudocode, we need to make sure that every module or every program begins with a main module, and we end that main module, and then we'll have some submodules beneath that to have that modular design. Alright guys, I hope I covered everything. I think I did. If you have any questions about any of that, let me know, and I'll be happy to help you out.